Let's do a quick video on how to sketch the graph of a radical function. This is part of Unit 8, where we're working with radical functions. And as we've come to see with other types of functions, we can key in on some of the structure of the radical function itself to determine whether or not there's a horizontal shift or a vertical shift. But the first thing that's always most important when we're learning how to graph certain type of function is to understand what the default graph is, or the parent graph. So what is the parent graph of the radical function, which we can say y equals the square root of x? Now remember, x squared, y equals x squared, is a parabola, right? It looks like this. Well, y equals square root of x is just that parabola set on its side. Okay, but we only care about the positive values in this function because it's not really a function if we keep the negative values. Remember, it wouldn't pass the vertical line test. So to keep it a function, we just keep the positive values because a negative value under a radical is going to be a complex number. So this is the top half, which is the half we care about. This represents the parent graph of the function y equals square root of x. Okay, and so if we start taking a look over here at our first example, y equals the square root of x plus 5, we have a vertical shift of 5 units. So we have literally the same exact graph, but we just shift vertically 5 units. Now, how do I make sure I'm catching some of these extra points? Well, we can actually just do a quick table of values with a value that's that's a perfect square, like 4. What if we put x equals 4 in? We're going to have the square root of 4, which is 2 plus 5 is 7. So 4 goes to 7. Boy, I was pretty close when I drew that graph. Okay, so that's the graph of the square root of x plus 5. If we look at this next one, we have a scalar out front, which is going to change sort of the shape of it, make it maybe a little bit steeper. But here we see a horizontal shift where we're going to move 2 units to the left. And how do I know that? Well, if we put in a value of x of -2, that's going to give us the square root of 0, which is 0 times -2, which is 0. So our graph is going to start at x is -2. And it's going to go down because this negative value on our coefficient out front is going to flip the direction of it, and it's going to go this way. But let's make that more precise by putting in another value. So let's put in some value. Let's put in 2 for x. Why? Because 2 plus 2 is going to be, 2 plus 2 is going to equal 4. And we like to have a nice squared value under there. So the square root of 4 is just going to be 2. 2 times -2 is -4. So we say the value 2, -4 is on the graph. So now we can complete the graph with our basic form of the square root function, okay? So that's what that looks like. In this last one, we have both a horizontal shift and a vertical shift going on. Our horizontal shift is going to move it down 2 places. Our vertical shift, our horizontal shift is going to move it 4 places to the right. Our vertical shift is going to move it 2 places down. And there's nothing else to contend with, so this is just simply one of these guys, okay? Now the question is there another value that crosses? If we put in the value 8 for x, 8 minus 4 is 4. 8 minus 4 is the square root of 4, which is 2 minus 2 is 0. So I drew that a little bit too sharply. We need to go through the point 8, 0. And again, I'll show you that again. What I did there was I put in an x value of 8, and that gave us 8 minus 4, which is 4 under the radical, which equates to 2 minus 2, 0. So 8, 0 is a point on the graph. That's how we graph radical functions.